Hello, welcome to a talk on observability and practice in Kubernetes around Spinnaker. My name is Jason McIntosh. I am a staff engineer at Armory. We're going to be discussing a couple concepts based upon experience that we have writing the observability plugin and overall observing Spinnaker across multiple environments. I've been in this space since the early days of Nagios, when the concept of observability is, okay, the server hasn't melted down, or, oh yeah, we don't have temperature alarms going off. Well, things have changed quite a bit, and particularly in the last few years, there's been a lot of new innovations and a lot of new concepts. So we'll go in through and discuss some of those today. But let's start off with, of course, I got a presentation. We got to have the paperwork, but let's get it started. So, I said, Jason McIntosh, staff engineer, working at Armory, particularly on the observability plugin. But let's start off. What is observability? And this is a direct quote from Charity Majors, although she's pulled it from engineering and other systems. But observability is a measure of how well internal states of a system can be inferred from the knowledge of its external outputs. So, what does that mean? When we start talking about outputs, that's stuff that we can see coming out of Spinnaker. That's metrics, logs, events, streams from Echo, events or things going on with this system. That's required to observe how well caching is operating or various pieces and parts are actually behaving in the system. So if you can't get that information, you can't observe it. And if you don't have enough information, you're not going to be able to observe it. So what does that actually look like? Well, what do we have today? Metrics. Spinnaker uses a library called Micrometer, which wraps Spectator, an FX library. And you have gauges, counters, basically a field that is a specific name, i.e. execution time. A lot of tags, descriptions, labels around that, and then a value. And then in some cases, you may have a timestamp with that, depending on the metric provider and system you're using. Metrics are great. You can generate some very pretty dashboards that can show, hey, look at how many pipelines we've executed over the last day. They also give you a very quick, high-level visibility in the overall behavior of your system, as long as you have the metrics there. Spinnaker, thankfully, is very verbose on its metrics. I think in one of the systems I was pulling out 70,000 a minute, or 70,000 unique metrics with all the labels included in the cardinality of those metrics. So you can get an inordinate amount of data from it. Very, very useful, but just be aware, it's a number, so you can be somewhat limited. You have logging. Everybody deals with logging all day long. Hey, I did such and such. Well, logging's great. It's very useful. You can get a whole lot of information around stack traces and errors, but it's extremely verbose, and it's very hard to graph text data without translating into something that you can run analytics on. It's typically stored in an ELK type system, which is a Lucene text index. You can use Splunk. You can use any of your logging frameworks, CloudWatch, similar. But if you want to know errors, that's one of the core places a lot of people go to say, why did such and such just not work? Well, sometimes you just need to have the system tell you why it didn't work. Tracing. This is something fewer people have probably heard of. So tracing is tracking a request through the system. When somebody hits gate, the API layer, it's tracking through that, okay, gate made a call to fiat, which then made a call to cloud driver, which returned to fiat, and telling you the performance and the transactions through each one of those pieces and parts in the system. Dapper would be an early example from Google side of things. You'll hear Zipkin, Cloud Sleuth, and then a lot of your APM agents out there in the marketplace will add distributed tracing through injection into the JVMs or into whatever processes you're running. Very useful on all of these. This is how you can actually trace through and say, okay, somebody hit the API. Why did it take 5 seconds? Well, most of your tracing can say, okay, hey, gate was fine and fiat was fine, but cloud driver took 1.5 seconds. And that's how you can narrow in on where some of your problems are. Problem with tracing is it doesn't always tell you why cloud driver took 1.5 seconds. So just before we dive in a little more, metrics, traces, and logs are not necessarily observability. They can be used for monitoring. Metrics in particular are very heavily used in monitoring to know that Spinnaker's up and running, but they don't always tell you or give you enough information to know, hey, why did such and such happen in the system? That's an extremely difficult problem to solve, but we can get a lot of information that may get us observability. Do be aware there's a number of discussions, and I'll reference a couple of those in this around observability versus what you'll typically hear as the 3 pillars: metrics, traces, and logs. But do be aware there's some debate that that doesn't necessarily mean observability. And when we start talking about this, don't ever forget these systems outside of Spinnaker. Spinnaker runs and depends on Redis. It depends on MySQL. If you're not monitoring those platforms and you can't observe the behavior of those platforms, you're really not observing the whole system, just pieces and parts of it. Now, sometimes you'll know, hey, the database is slow, but don't forget to monitor that, oh yeah, your IO rate on the database is also possibly problematic. So metrics. We get a lot of metrics from Spinnaker. Here's an example of one. Okay, HTTP request counts over 5 minutes. But is it useful? Well, it depends on what you're trying to answer from a question perspective. Sometimes there are certain metrics that are probably looked at way more heavily than others. For example, queue depths or execution times. But some of those, yeah, we may not use until you start trying to trace through, like, hey, why did a caching agent take long? And you start looking at the performance of some of the Kubernetes caching agents and timings there. So you have the metrics, but you do have to have sort of an understanding of what you're looking for, what you want to try and answer. And then maybe that metric may make sense to you. And different organizations will have different perspectives on what is useful. There are some considered common metrics, and that's where we have some of the centralized dashboards. So there was a Spinnaker monitoring project that had quite a few. We haven't had much luck with those dashboards, and it's not as well maintained. We've found that the Python system that it runs with to be somewhat problematic. So that was actually one of the reasons that Armory released the observability plugin, was to try and resolve problems with that. So part of that, though, is there are updated dashboards with this, thanks to Carl and the Unique team. So I'll have links to that at the end, and we'll show a couple examples of those dashboards here in a minute. But logging, ton of information, almost too much. The default tends to be an info level log. You want to capture it, because if you ever do need to try and figure out what's going on, you're probably going to want to look through your logs. But I've seen situations where the logs show, okay, no pointer, but it doesn't tell you where, why, or any of the details around the parameters on it. So do be careful of it. You want it. You want to be able to look through it. But there is so much information in the logs that it can be just overwhelming. There was an interesting article that talks about, hey, leave your logs at like a warning level, but have the ability to dynamically adjust your log levels to improve the depth and scope of the information, so you get much more visibility in an error situation. There's lots of systems, lots of discussions. At one point, there was JMX connectors you could hook in to change log levels. Debug logs, when you turn them on, are going to be exceedingly verbose because of the Spring levels. So you may also need to target some of your logs. Capture them, look at them, but do be aware that, yeah, unless you're having problems, you may not actually pay that much attention to it. But if you are having problems, you're going to want to look at them. So just be aware that you're going to have to filter through a whole lot of stuff to find those gold nuggets in some of these. Tracing. I've got a screenshot here from the Zipkin homepage. And this is an example I talked a little bit about before, where you can trace through from the point where a system is entered, i.e. gate, through the various pieces and parts that gate would communicate, including those pieces and parts. It keeps track of a span ID, and it lets you track all of those up to a root span. And then you can see all the timings on it, which gives you resulting time overall. So from their screenshot, it looks like their mobile API post locations update took 56 milliseconds, and that was the biggest part of it. And that's really useful when you're trying to say, okay, was it Cloud Driver? Was it Fiat? Was it Orca that took some time? Pretty useful. Definitely something that you need in modern systems. So let's take a look at all three of these together, as well as some other things here. So as I said, we came out with the observability plugin because the metrics that we were seeing, we were having problems getting them. Some of the cardinality was an issue. Further, we were looking at a lot of the metrics that were coming from the monitoring system were broken down with service as part of the metric name, which made it much more difficult to organize, filter, group by, etc. So put out the observability plugin. It natively supports Prometheus and New Relic. It would probably be very easy to add some of the other vendors in there, as long as it's a micrometer library supported. So I'm not going to go through the full list of that, but just be aware those are the ones we started with. Does not add tracing, as said. That's your Spring Cloud sleuth. It's something that we've considered, talked about, but have been hesitant to add at this point. You can also go get tracing through many of your APM vendors that would automatically add it to your HTTP requests. Logging, also not covered by the plugin. There are so many existing logging solutions, and typically this runs independent of your clustered environment. With that said, you want to learn more about logging, there's a logback framework where you can tweak a lot of Spinnaker's logs, but a lot of companies will use a FluentD to ship logs to a remote platform. Plugin, it's a start. We're always open to improvements. We're trying to improve it, pretty constantly. So if you got contributions, please bring them along. And again, thank you to those who are already contributing. So let's take a look at how this works. I'm going to borrow an environment that I stood up, customized patches, running a local micro K8s. There are a couple things. Make sure your environment's up there, that you have some of your metrics configuration. I went ahead and installed, for example, the Prometheus operator, the Grafana, and all of that system, and built the environment. I'm not going to go into details. I will go ahead and say, hey, when you want to enable the plugin, the docs are on the plugin site. Just make sure you watch the spacing. I just shot myself in the foot because I put Prometheus up at the config layer and it's under the config layer, for example. This adds a new endpoint, AOP Prometheus, to these services. One caution flag on this. Gate, since it's usually publicly accessible, and to make the endpoint publicly accessible, you have to expose it through the management endpoints. That makes it accessible through curl and Prometheus scrape, for example. As soon as you do that, somebody else in the internet could be able to scrape your metric data. You may not want that to happen. So you would probably want to filter that at your edge layer in some fashion, either through an ingress routing rule or some other mechanism. I'm not going to go into the details of some of that. Be aware that it is, though, the Spring management endpoint. You can do some of the things like setting username and password. Read the documentation for more information on some of those options. Changing the port, not really viable at this time, although there's been some discussion around it. So with those said, do be cautious of that. So as said, I'm going to borrow some of the dashboards. Thank you to the Unique team. They require JSONnet, and they also require Prometheus and monitoring configs. So let's go ahead and bring that up and see what that looks like. So I've got a Grafana environment stood up right now. I also have in my background a Prometheus environment where I've port forwarded it. And what we actually have here is, I'll start off with a key metrics database. And I'm not going to go into the details of all of the different dashboards and information that we get. but you can see some of them here. Now, being a test environment, I don't have it hooked up to AWS, and I don't have it set up for Jenkins and Bakes. So there's a number of things that I'm going to be missing here. But you can at least see, hey, we have some data, color invocation rate. We can actually view this in greater detail. And let's see here. If we want to, we can look at the model for how this was generated. Very useful. Anybody has access to it, but we are occasionally finding things. So feel free to look at some of these and offer improvements. If we actually look, we can see some of the different data that we come in, and hey, we can look at the history on it. So I'm not going to go through all the Grafana options at this point, but do be aware there is a ton of data that we don't always generate dashboards for. So if we look through Prometheus, you can see, for example, one of the ones I look at is long garbage collection pauses. We'll run our query, and you can see, yeah, we're all under a second. We're perfectly fine from this case. There's, as said, a ton of metrics. Feel free to dig through some of these, find out what you like, request counts, and all kinds of other information on it. So for more information, you're welcome to ask in the monitoring channel, look around. There's blog posts. I'll have several linked. But these are some example queries that you can run. I tend to like to look at, hey, how's the performance of all of my pipelines? Are they executing? How many are failing? And breaking them down by application and their state. Do like to look at execution time just to keep an idea of what's going on. But very good dashboards. Look at them, use them. They're very handy when you're trying to figure out what's going on. I'll talk real quick about APM and just show a quick demo. I borrowed a free New Relic account to demo this. These metrics, monitoring and logging, very handy, but you don't always get full details, because what happens about a piece of code that nobody's added a metric to, or is an exception that gets just eaten? There are times where APM agents can be very useful on some of this. So I have just up here a demo environment where I have added some basic transaction monitoring. APMs will a lot of times show you different endpoints, their performance on it. For example, here's Cloud Driver, and it breaks down application performance into response times and gives you a whole lot of detailed information. You can get a lot of this same information from your dashboards, wherever my links are. I think I may have shut down the Grafana one. Back to it, you can get a lot of the information from your dashboards and from your internal metrics, but there are things that you can do, for example, with thread profiling that you wouldn't necessarily be able to do without having access to an JVM agent. These thread profiles let you inspect and say, oh yeah, what is actually going on? Well, in this system, not much. Most of the stuff is parked and just sitting there waiting for things to happen. Because guess what? It's a test environment. On an actual production system, though, you will see a lot more going on, including things like performance of your different agents, where time is spent. It can be very useful when you're trying to track performance and what's going on with your system. So APMs can be very handy, but just like anything else, you have to spend some time looking at them, figuring out how to use them. But as you can see, there's an example of a caching agent which shows a spike. Oh, this is talking to an EC2 instance, and it took a little longer than expected. Doesn't mean it's out of the realm of possibility, because hey, if we look at application time, most people don't know it, but it would be useful for debugging caching times. Handy also can get you your tracing information. I don't believe this system I have fully wired for distributed tracing, mostly because, again, this is a test environment, so there's not a lot of data. As you can see, there's almost no spans. But if we look at an example of a span, you can see, oh yeah, hey, this came through, hit these different systems, talked to SQL, and one of them was getting load balancing that took a little longer. So again, very useful. Most of your systems, you can absolutely do this. It is useful for diagnosing problems. Capture all the data. You never know what you're not going to know. So the more you capture with the more depth, the more you're going to be able to identify problems in the system. This includes things like your logs and capturing debug logs and being able to dynamically adjust to that when there's problems. Be prepared for some of that because it's going to happen. Everything has its issues. I was just debugging today a problem with database slowdowns and it crashed Cloud Driver. Having some of this information, you can then track through that, oh yeah, the database is slowing down. Do be aware, Spinnaker is very verbose on its metrics, so you can get an absurd amount of cardinality. That means even though you may be only publishing, say, 5,000 or 10,000 metrics a minute, because of the unique amount of labels generated with each of them, you may have 70,000 unique metrics in any given system over a period of time. It's incredibly useful. It provides incredible detail, but there is a caution flag, particularly if you look at the stack driver Spinnaker documentation. So they will even issue a warning on some of this. Doesn't mean it's wrong, but do be aware that there is some gotchas with some of these platforms and how they handle that. So if you get a rather large bill at the end of the month, don't come back and complain. You've been warned. Still useful, still want the tracing, you still want the logs, but as I said, sometimes none of this really provides the answer. APMs can help. The other thing is looking and turn on debug logs. Also, echo events. Echo events will provide also quite a bit of information. And at the end of the day, ask for help. There's a lot of things out there that information resources. I'll link a few towards the end. Absolutely amazing blogs. There's a Slack channel. We can answer more questions and try and provide analysis. And the dashboards, they're constantly expanding. So as you find things, please do pull requests. Help share the knowledge. There's always constant room for improvement. So a couple of resources I'd like to reference. Thank you for Netflix and the team who have put together some pretty good dashboards, presentations, blogs. The Armory Observability Plugin. This right here is open source. You're welcome to come download it and give it a try. Please give us some feedback. A big thanks to Charity Majors. If anybody isn't aware, Honeycomb, she does some very good talks around observability and the fact that 3 pillars aren't observability. They're really more monitoring, but you can achieve some of the observability with some of that. So I'm trying not to paraphrase some of her content on that. There's some other very good articles on there. Read around, ask around, learn. The market is always changing on this, and there's always new ideas and new ways to do things. So with that said, here's the plugin. So in conclusion, observability plugin with Armory filters helps reduce a little bit of the spend, can reduce some of the metrics you're doing. It's a great tool, highly recommend it. APM, application performance monitoring, is a very good tool to complement the observability plugin for additional introspection and visualization into your JVM. Again, capture all the data that's reasonable. Look at everything that you possibly can. Also, don't forget about echo events. Everything that happens in Spinnaker should go through an echo event. You can turn on a fire hose and collect a whole lot of data from that. So don't forget any of the systems that you have for collecting information.